So first question, why do we need this algorithm? Why do we need binary search? You need binary search to know efficiently whether a element is present in a list or an array or is not present, right? Now you must be wondering, well, we have linear search for that. We can just go linearly and search the array and see whether it is present or not. Well, you are very right. But the problem with that is that, well, the time complexity of binary search is just big of log n, right? Which is way faster than just linear, right? It is logarithmic time. So that's why you need binary search to search whether an element is present in a list or not. And the whole point of learning algorithms is to do that efficiently, and binary search does that work more efficiently than linear search. So that's why we need binary search. Now, let me explain you how this algorithm works, and then we'll see the code and also we'll run it and see whether it works or not. Okay, so I'll be explaining two cases. In the first case, we will find out the element we are searching for, and in the second case, we will not find out, so that you can see how this thing works in different cases, right? Okay, so let's say this is the array we have been given 45821, and this is the search element. The 2 is the thing we have to search for in this array using binary search, right? An important thing with binary search is that it is a divide and conquer type algorithm. So if you're wondering what is this, so this is a paradigm of algorithm where the algorithm divides the thing it is working on to make the time complexity really efficient, right? So you'll see how everything works. So the first and the foremost thing you need to just know is that before you start implementing the binary search algorithm, you have to sort the array. And why do we need to sort the array? We will know everything. So let us for now just sort this array. So and if you sort it, you will get something like 1, 2, 4, 5, and 8, right? Cool. So now that we have sorted this array, so let's see how this algorithm works. Okay, so basically with binary search you just need to play around with these three variables. First is the leftmost position, the second is the right position, and the third is the middle position, right? And we will be maintaining this things in a table, so I'm just arranging this. So now if you see what is the left position now, where we are. So at first the left position is always obviously 0, because first we obviously we are starting from the first, right? And obviously the rightmost position is at the end, so it's as it as it is a zeroth indexed array, we will start by 0, 1, 2, 3, 4. So our r is now 4, l is now 0, and middle element, the formula to find the middle element is something like mid is equal to l plus r by 2, right? So if you apply this formula, you'll get the middle position to be how much? 2, right? 4 plus 0 by 2 is 2, right? So let's just let me just put it in here to just see things. Okay, it's 4042. So as you can see here, I've written some things here, and you'll see how this things works. Okay, so now every time we have updated these three variables, we need to perform some checks and see where are things going. So as we have updated these things here, first we will go through this check. Okay, is what does this mean is that is our middle element, or our or the position, or the element in the middle position is equal to the search element. So here the element in our middle position is 4, and is the 4 equal to 2, which it is not, so this fails, right? So now let's do the second check, that is the middle element less than the search element. So is 4 less than 2? No, it's not, so that fails too. So let's go to the third check, that is the middle element greater than, so greater than search element, right? Which is totally true, right? So as you can see here, what we do here, if this is true, is that we get the r to mid minus 1. So that means that according to these checks, somehow r is equal to, will be now equal to a mid minus 1, that is 1. Well, why does this happen? So now listen carefully, because now you will understand the division part, why this is a divide and conquer algorithm, and why we sort things here. So as we found out here that the search element is less than the middle element. So what does that mean actually, right? So as we know, we have sorted the array, right? So now if some element is less than the middle element, where should it lie? obviously as the array is sorted, it should lie in the left part of the middle element because it is sorted, right? So that means that this part of the array is of no value to us now. We know now that the element we are searching for exists somewhere in the left part of the middle element, which means somewhere here the thing exists, right? So we don't need this anymore. So we just need to discard this part of our array. Well, how do we discard it? So we discard it by just not considering it or just ignoring it. Well, how we ignore it is that we just update this right part to this mid minus one part, right? So we just update this right position to this position, which is mid minus one, just the element next to the mid here. So this is where our left rightmost position is now updated, so that we just ignore totally this part, right? So that means that we have to update these things now, right? So as our search, so just summarizing it, our search element is less than the middle element, so we don't need to consider everything from the middle element to the last. We know something that we are searching for is on the left side of it, so that's why the right position is now updated to mid minus one, just the element before the mid. That's the point up to which we are considering now. This part is just gone, right? So our r will be mid minus 1, or mid was 2, and our r will be now 1, and left will stay as such because we are just considering till the end now, so it will just remain as such. Now let us calculate the new mid. So according to this formula, 0 plus 1 by 2 will be 0.5, but we will just consider the floor part, so 0. So now, as you know, our L is now 0, our mid is also 0, and our R is 1, right? So let us write here, this is the point. So R is equal to 1, which is this thing, right? So we are considering now this part, right? So that's how the division occurred, right? We don't need to consider this part now. So that's how it is dividing and conquering things. Okay, so now that we have again given this values, updated values, we need to go through what? The checks, right? So let's go to the first check. So is the middle element equal to the search element? So now the middle element is 1. Is it equal to the search element, that is 2? No, it's not. So well, we need to try the next one, that is the middle element less than the searching element? Yes, it is. Well, what does that mean now? So that means that the element you are searching for is on the right side of the middle element. Why? Because it is sorted and the searching element is greater than the middle element. That means obviously it is on the right side. So that means that everything that is on the left side, including the middle element, should be discarded, right? So you have to discard this thing, and we have to just consider this thing right now, right? So this thing is to be discarded totally, right? So how to do that? Well, we can just do that by just getting that L, getting the leftmost position to mid plus 1, just the next position of the middle element, right? Which is what I have written here, right? When this is true, you have to L is equal to mid plus 1, right? So that means our new L will be mid plus 1, that is 1, and the right position will just remain the same, and 1 plus 1 by 2, it is 1, that is 1, that is the new mid element, right? So now that we have again updated the value, great. So now that we have again updated the value, let us just write here. So our L is now 1, R is also 1, and mid is also 1. So all of these are pointing to this, right? And if we see now, we have updated the value, and now let's do what we do again. Just check these things, right? So the first check is obviously the middle element is equal to the search element. So now the middle element is 2, and our search element is 2. So that means that we have found the thing we have been looking for, and we just return true. And that's how binary search works, right? It just, so the point of this checks is that to know the position of the thing you are searching for, and just to discard things and just get nearer, 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 and somehow just hit it, right? So that's the whole point of checking these things and maintaining this positions, right? So this is the example where you find the thing you are looking for. So now let us see an example where you just don't find the thing you are looking for. What happens in that case? Okay, so this is the second case. Here you are not going to find the thing you are looking for. So let's see how the algorithm works in this case and how it shows us that it does not exist, the element we are searching for. Let's say we are searching for 6, right? Great, we are searching for 6. Okay, so the one thing I did not. Okay, so the one thing that I did not mention in the first case is that there's a bigger check in front of all these checks, which is left less than r. If this condition is satisfied, you will proceed to these three checks, else you will just return false. And you'll see how. So when the element does not exist, this condition will be false, right? Because logically the left should always be in the left side and the right should always be in the right side. It should not, the left should not be greater than the right side, right? Because we are sorting and the left should always be smaller, right? So you'll see. If you're confused, don't worry about it. After this example, you will not. So let's say our search element is 6, right? So, well, we are now, our L is now at 0. We are here. Then our right is at 4. As we know, we are starting out. So mid is equal to 2. Great. So the first check, is left position less than right position? Yes, it is. 0 is less than 4. So this is true. So we proceed to the next steps. So the first check, the middle element is 4 and our searching element is 6. So is it equal? No, it's not. So that has failed. Let's proceed to the next check. Is the middle element less than the search element? Which is true. So what do you have to do? That means that the search element is greater than the middle element and that it is present on the right side of the search element, somewhere in between here, right? Not, definitely not in this side. So you have to discard that. So what do? You move this left. So you move the left position to mid plus 1 to this position, right? So we'll update our left values now. So our L value will be what? Mid plus 1 because we need it here. So it will be mid was 2. So now L will be 3. R will remain the same. Now the new mid will be 4 plus 3 by 2. 7 by 2 is how much? 3 point something, I guess, but we'll take 3, right? Because we are always taking the floor, right? So now we have updated that in. So this will be the next step. We have discarded this part. We have discarded totally this part. We are just now operating on this side. So new L will be how much? 3, 0, 1, 2, 3. This one. Then our mid is also 3. Mid is also 3 and our right is totally the end one, r is equal to 4, right? So that's how we are proceeding till now. Great. So now as we updated the array, let's do the checks first. So is L less than r? Yes, it is. 3 is less than 4. So is the middle element equal to the search element? Middle element is 5, right? Is it equal to the search element? No, it's not. So that has failed, obviously. Let's proceed to the next one. Is the middle element less than the search element? Yes, it is less than the search element. Well, what does that mean? That means that the element you're searching for, that is 6, obviously is present somewhere after the middle element, right? So somewhere around here. So we need to also discard this thing, right? We need to also discard this thing. So what we have to do is that just move this L to here, that is mid plus 1. So the new L will be how much? 4. Mid plus, because 3 plus 1 is 4. Then R will remain the same and our mid will be 4 plus 4, 8 by 2, that is 4. Great. So now let me just write this thing. So we have discarded till now these things, right? So here we are now. L is equal to 4, R is equal to 4, mid is also equal to 4. Great, right? Okay, sorry, a little mistake, but that's not the problem. It's not actually less than R, it's equal to less than equal to R, right? Because if it was less than R, it fails at this point, right? Which should not be, right? Because imagine we are searching for 8. We have to pass this check, right? So that you can get to this check and you can return true, right? So yeah, that was a little bit of mistake from me, pardon me. So it was less than equal to 8, right? So now is 4 less than equal to the middle element? Yes, it is less than equal to, because it is equal to 4 is equal to 4. So let's just get into other checks. So is the middle element equal to the search element, right? Is 4 equal to 8? No, it's not. Now the next check, is 4 less than 8? Yes, it is less than 8. Well, what does that mean? That means that our thing that we are searching for exists somewhere after this thing, right? Well, that's ridiculous, and the program will know that it is ridiculous. Well, how? So when it is now updating, what you'll do is that what should you update now? As it is greater, we have to shift this L to the mid plus 1, right? So what will be our L? Our L will be 4 plus 1, that is 5, and R remains same, and this thing, the mid is how much? 9 by 2 is also 4, right? Great. We go to our next thing, and in this next thing, what it will do is that now it will check this thing. Is left less than equal to r? Now our left is 5, and our r is 4, right? Is this happening? No, it's not. Well, that should not happen. That is ridiculous, right? And that's how the program knows that we have crossed this limitation, which should be there, that left should always be less than the right one. So that means that whatever you're searching for is not present in this current list, right? And that's how it just returns false. So this is the algorithm we had discussed. This is the binary search algorithm. You see, first is left is less than equal to r, that we had discussed, and if somehow this is not true, that means that the thing that you're searching for does not exist and you have exceeded the array somehow. You're going ridiculously somewhere else, right? And you'll return false if this is not true, right? This is not true, you'll return false. Else what you do is that you, as you know, the formula for mid, left plus r by 2, we find the mid, and then we perform those 3 checks that I showed you, right? That I showed you. The first thing is that is the middle element equal to the search element? Is it less than or it is greater than? If it is equal to the search element, we return true. If it is less than the search element, that means the search element is greater than it, exists on the right side, and that's why we do mid plus 1, mid plus, and that's why we need to bring that L to mid plus 1. We discard this part of it because we know the thing exists on right part, and the right remains same, and we again, recursion occurs. We again repeat this process as I have written here, or we repeat this process. L is equal to mid plus 1 and repeat. Okay, and here, as the search element is less than the middle element, it exists on the left side of this whole array. We now, as we know, it exists on the left side, we discard this part, so we bring the right part to mid minus 1, just the element before mid, and exactly that what we do here. In the where it takes right, we pass in mid minus 1, and it just gets repeated, recursion occurs, and according to that it returns things. So I have already compiled it, so let me just show you how this works. Okay, so let's see our first example. So it was 4 4 5 8 2 and 1, and let me search 2, right? It found the element, right? Okay, so now let me search something that we should not get, and like the second case that we discussed. So let us search 6, and the element is not present, right? That's how binary search works. So that is how the binary search algorithm works. And do let me know your thoughts in the comment section below so that I can improve, and also what do you think of this video. And if you learned something from the video, hit that subscribe button. That means a lot. And if you love this video, share it in your socials, tag me up on Twitter. It will be great to connect with you. And I will be coming up with next algorithm very soon. Till then, have a great day, and I'll see you in the next one.